Thanks, David. So yeah, my name is Eben Upton. I am one of the founders of an organization based in Cambridge called Raspberry Pi. We make these things. Does anyone in the audience have one of these things? Oh, there we go, that's nice. Yeah, so this is a $25 Linux microcomputer. As David said, this is something that came out of the desire to do this, the desire to build this. This has taken us about 6 or 7 years to bring from kind of concept to reality. And the desire to do that came out of this horrible realization that a group of us at the university had in the middle part of last decade, that all of our prospective undergraduates had disappeared. So when I was about 10 years old, I bought a machine called a BBC microcomputer, which those of you from the UK who are roughly my age, I'm sure, have spent time playing with. And this was a wonderful machine. I first encountered this at school. And the wonderful thing about this machine was that you would turn it on, and it would go beep. And you might have this machine for any number of reasons. You might have bought this machine to play games on. You might have bought this machine to do your schoolwork on. But you would turn it on, and it would go beep. And the very first thing it would do is present you with a programming prompt. And if you wanted to do something other than program your BBC, the first thing you had to do was you had to choose not to program your BBC. The default choice, if you like, with this platform was to become a computer programmer. And so virtually everybody my age at my school knew at least how to write that 2-line computer program, 10 print I am the best, 20 go to 10, or 10 print something much filthier than that, 20 go to 10, and then go to Dixon's and type it into all of the machines and hit enter and run out the door. And this was absolutely wonderful. And this was wonderful for people of my generation. It was also wonderful for organizations like the University of Cambridge, because what it provided us with, when I arrived there in the mid-1990s, it was providing the university with a stream of people, all of whom had already got their Malcolm Gladwell 10,000 hours of hacking at the moment they came in the door. And in fact, the first thing you have to do with people like that is you have to beat them over the head with a stick and convince them that there's something left to learn. But this was wonderful for us, because the university has notoriously short terms. We have 60 weeks to turn you from a high school student into somebody who can start a 3-year UK PhD program. And so having people coming in the door with some level of familiarity with technology was extremely useful to us. We had a fairly typical Cambridge application ratio. We had about 80 or 90 places, and we had about 500 people competing to fill those 80 or 90 places, and so this was wonderful for us. By the time I got involved 10 years later in interviewing people to come and study computer science at Cambridge, those numbers had declined precipitously. Those numbers had gone down to maybe 250 people. Which was bad in and of itself. We were still finding enough people, we were still finding fearsomely bright people to come and fill our places, but it was starting to get to the point where we thought if this carried on, then we were maybe going to start to have some trouble in a few years' time. But much more worrying for us is that many of these people, while still very bright, were coming in the door with no real familiarity with the practical craft of computer programming. So a group of us at the university started to wonder, well, what had happened, and whether there was something we could do about it. And the hypothesis, and it still is a hypothesis, and I think it will remain a hypothesis for several years, is that the disappearance of those open programmable platforms that lure you into programming, machines like the Commodore 64, the BBC Micro, the ZX Spectrum, those machines that I grew up with in the 1980s, the disappearance of those devices and their replacement with an entire ecosystems of fixed function devices like set-top boxes and games consoles, mobile phones, tablets, their replacement by those, and also their replacement by the PC, which, while programmable, is certainly a much less approachable programming platform than those old 8-bit microcomputers. That had cut the legs off our supply of young people. And in terms of a solution, so we started to wonder whether there was a niche, whether there was still a niche for a machine that could go into a child's bedroom that was interesting to a child. We started to wonder whether we could build something which was still going to be interesting enough, which combined being interesting enough to children that they were going to engage with it and they were going to take it into their lives, but that retained some of that programmability that we thought maybe had been lost. And so I guess that was about 2006. We spent a long time trying to decide what we were going to build. But we very quickly came on the idea that if we were going to build something, if we were going to ask people to buy a special piece of hardware in order to learn to program on, then that piece of hardware had better be very, very, very cheap. And we settled on the idea of $25 as a price point for this thing. And $25 came from our notion of, well, what else can you ask a child to buy for education? Well, you can ask a child to buy a textbook. Schools routinely ask children to buy textbooks. And we thought that school textbooks cost $25, which I understand from some parents is a little bit of an incorrect estimate. I think if we'd had a better idea of what school textbooks cost, we might have an easier job of the engineering over the next few years. But we settled on this price point really before we had anything else. And we tried a bunch of different things. And by about 2011, we really felt that we had something which was really going to fly for this target market. And we had these very, very small ambitions. So our small ambitions were just to try and solve this little problem we had at Cambridge. And we really felt that we could solve this problem with 1,000 devices. We thought we could make 1,000 devices. Because remember, we're trying to get from 250 applicants to 500 applicants. And we're trying to increase the level of skill of the 80 or 90 people we take. So we thought 1,000 computers would be fine. And because we're quite nostalgic people, and many of us have a history with the BBC microcomputer, we thought it'd be lovely to stick the BBC brand on this. And we kept going and seeing the BBC and saying, go on, let us call this a BBC microcomputer. And the BBC kept saying no. And our last attempt to do this was in May of 2011. We went to see a gentleman called Rory Kethlin-Jones, who's a BBC technology correspondent. And we asked him, could we call this a BBC microcomputer? And he said, almost certainly not, but could I take a video of it and put it on my blog? And because we're complete imbeciles, we said yes. And he took a video of it and put it on his blog, and he got 600,000 YouTube views in 2 days. And those were wonderful 2 days for me, because I just sat at my computer pressing F5, watching my how popular are you counter going up. And at the end of the second day, I sat down for dinner with my wife, and I was feeling really, really happy. And we looked at each other across the table, and we had this sudden, terrible oh shit moment where we realized that we had promised 600,000 people that we were going to build them a computer for $25, and we had actually, in practice, no idea about how we were going to do that. So I had a really busy 2011. We managed to get prototypes out the door by the end of the year. We went to production in the February. We were scaled as an organization. We were not for profit. We were scaled as an organization originally to build 1,000 computers, maybe 10,000 computers. When we saw these 600,000 views, we thought we'd better scale up a bit, maybe 10,000 computers. We sold 100,000 of these on the first day. We took down the websites of both of our distributors. So then we had a very busy 2012, trying to figure out how to deal with this unexpected spike in demand. But really, 2013 has been an absolutely fantastic year for us, because we've started to see both enormous interest in this in markets that we had never imagined. You know, we were interested in selling these to children. We found that for a good part of the first year, almost all of these were selling to adults. Almost all of these were selling to people like me, who are, grown-ups who already know about computers and have a thing that they want to do. And it turned out, I think, a lot of this surprise upside that we've had in demand has come from the fact that there was just this wonderful, in the developed world, this wonderful latent demand among adults for a piece of Lego, a Lego brick that they could use to stitch together various other bits of electronics to accomplish something they'd always wanted to accomplish and hadn't been able to accomplish, or hadn't been able to accomplish at a reasonable cost. So we're about 20 months in. We've sold about 1.8 million of these. We build about 150,000 of them a month, and we build them in the UK, which is kind of weird. We started off building them in China because we thought, like everyone else, when you build cheap things, you build them in China. The real surprise for us midway through last year was to discover that we can build them in Wales more cheaply than we can build them in China. So these things are rolling off a Sony production line in Bridgend today. Probably about 5,000 of them will roll off a production line that used to build CRT televisions back in the 1990s. And things are going really nicely. And we're actually starting to see some evidence that we're having an impact in the educational environment, in the developed world educational environment, which was the place that we were interested in, the UK and developed world education environment. We're actually seeing evidence that children are using these to get their first programming experience. I think it's going to be a few years before we start to see more university applicants. I think our hypothesis is going to remain a hypothesis, maybe through 2020. But with a little bit of luck, we'll have made some progress. Now, I guess, alongside that unexpected market in the developed world, among technically literate people in the developed world, we've also started to see another unexpected market. And that unexpected market is as a low-cost productivity computer in the developing world. We talk a lot about what can we do with Raspberry Pi in the developing world. What can we do with Raspberry Pi? Particularly, what can we do with Raspberry Pi in Africa? And the interesting thing is, we try to engage with our community. And the interesting thing we discovered is really that it's already there. in all of these markets. To a very great degree, Raspberry Pi has got there ahead of our interest in getting Raspberry Pi there. We found particularly in Africa that there's a great tendency for people to buy suitcase loads of Raspberry Pis. And every time people working for NGOs will buy suitcase loads of Raspberry Pis and take them out to Africa when they go on a trip. And what this has led to is is projects in Africa that we know nothing about up until the very moment that somebody sends us an email or a blog post full of pictures. I mean, we've had pictures. We've done blog posts in the last 2 months about computer laboratories and hack spaces in Ghana, Cameroon, Malawi, and these are all things that we knew nothing about as an organization. So where a year ago we were thinking about engaging with the developing world, using this as a platform for bringing more people online, thinking about it in terms of what projects we could run, I think increasingly as an organization, we're thinking about it in terms of what projects are other people running, and how can we support those projects. The interesting thing about a lot of these things is how familiar the world looks, how familiar the organizations in Africa that are deploying Raspberry Pi look when we compare them to the equivalent organizations in the developed world. So these devices that are going out in sub-Saharan Africa are going out through hack spaces. They're going out through school projects, which are, so many of them are run by Western NGOs, but many of these are entirely local organizations which are finding ways to repurpose this piece of hardware that we developed for that we designed for the developed world. Excuse me a second. In an unfamiliar environment. So our challenge over the next year is really going to be to support these organizations in delivering Raspberry Pi into environments which are very familiar, to us. I think it is in a lot of ways. It is a foregone conclusion. Talking about bringing the next billion people online. I think in a lot of ways, it is a foregone conclusion that we are going to be able to bring another billion people online. I think it's very, if you look at the penetration of smartphones, you look at the penetration of tablets, you look at devices like Sunita is going to describe in a moment, you look at the popularity of these devices in the developing world, it's clear that there really is a massive demand for access to information, for access to platforms which give us many of the same facilities that we have, that we've become used to here in the developed world. I think for us as an organization, the challenge is going to be, the question for us is whether the devices that bring those next billion people online are, whether they're going to be devices like smartphones, whether they're going to be devices which are consumer devices, whether they're going to be devices whose primary function is to enable the owner of the device to consume content which has been produced by somebody else. I think this is a direction that we drifted in the West. This is the direction that we drifted in the West, which has deprived us of a supply of computer programmers. It's a direction which has given us a generation of consumers, not producers, a generation of consumption hardware, not production hardware. So I guess my big hope for Raspberry Pi in the developing world is that it's going to kindle some of what we're trying to rekindle in the West. It's going to kindle it's going to generate a group of people who see computing as an open environment, see computing as a platform for creating their own destiny, choosing their own destiny, not merely consuming things that we pushed onto them. So, yeah, it's been an interesting 18 months for us. It's been an interesting little while. And I do hope that as we push forward and as we start maybe to push ourselves outside our comfort zone a little bit, into places where we never dreamed Raspberry Pi would go, we can maybe maintain some of that spirit that we've been trying to develop in the West. So thank you very much for your time.
We have the slide up of the wired cover when we did the Raspberry Pi a couple of months ago. Evan, I just want to ask you a couple of questions about this. We've had two particularly high-selling issues this year, Virgin Galactic and this is not a conventionally beautiful Condé Nast cover, but there was something about this.
I'll tell Paul who designed the case.
But it's the heroic nature of this British upstart project that went around the world. Yet when you buy the Raspberry Pi, it doesn't even come with a box. It doesn't come with a manual.
Yeah.
It doesn't come with a keyboard or a monitor. Did you ever think we need to add these accessories?
We honestly thought we were going to sell 1,000 of them. Many of these accessories, the case is a fantastic example of this. We honestly thought we were going to sell 1,000 Raspberry Pis. If you design an injection mold for the upfront cost of that is going to be tens of thousands of dollars. And so we thought if we're going to sell 1,000 of them, that's $10 on every Raspberry Pi to pay for that, to amortize the cost of that injection mold. So lots of our decisions were driven by this completely broken idea that we had about how many of these we were going to produce. And the lovely thing about that is this wonderful ecosystem that's grown up. The case that you've got on the cover is nothing to do with us. That was designed by, in fact, the gentleman who designed our logo. It was designed and produced in Sheffield by an organization which has absolutely zero to do with Raspberry Pi. That's when I talk about trying to build an ecosystem of people who see this as a platform for creation. I think that the peripheral ecosystem around the Raspberry Pi is a really, really nice example of exactly what people do. And when people are taking this into Africa, this is not, generally when we're taking this into Africa, for example, we're not taking it in there as a charitable project. We're trying to find ways that we can support the same kind of innovation there that we've seen in the developed world.
I think the ecosystem's interesting. On Saturday, when here we run our event to inspire teenagers, Wired Next Generation, we got a workshop by, among other people, Kano, who are making educational packs, and they come with books. So you're providing extra opportunities for third parties. So last question is, you've achieved this phenomenal result. It's still growing. You'll probably have 2 million sold by the end of the year. Yeah. So what's your next project?
Yes. We don't talk about we don't talk about unannounced products. One of the really interesting things is how we've had to adapt to being a commercial organization that has things, when we did the Pi, the very first thing we did long before, when we were struggling through our exciting 2011, we had a blog where we talked about our struggles. And of course, now it's much harder for us to talk about what it is that we're planning to do next, because, we want to keep a little, almost a slightly commercial element of surprise. I think 2014 is going to be a very interesting year for us.
You let Wired know first.
Absolutely, always.
All right. Eben Upton.
Anyway, thank you very much.